exam, but I didn't give them an exam before the class to know how much physics they knew before, and an exam afterwards to determine how much physics they had learned. And we almost never do that. And the vast majority of us have no training or help institutionally from the university in accomplishing that task. It's interesting, we've seen this picture before, and I'm now going to use it in a different way. Our system of education selects for great experts, and here was one of the premier ones in the world, Richard Feynman, right? A great physicist. At least, and I've often heard politicians in the United States say, wouldn't it be wonderful if your sons and daughters could be taught by a Nobel Prize winner? No. He was a great physicist. Any of you who have ever read the Feynman Lectures on Physics, which are a series of 3 books on introductory physics, will know that those are wonderful introductory physics books as long as you already know physics. They're innovative, exciting, interesting, as long as you already know physics. It was notorious at the California Institute of Technology that only accepts the very best, that many of his students failed. Because he himself described the way, when he thought about physics, he could actually see the models. He could see the models in his imagination. Well, imagine how many of the students in his room had that amazing cognitive ability to just see the models in their imagination. So he's exactly what we wanted in a researcher. He was, without a team, the driver without the designer and without the pit crew. But wait, it gets worse. As we become more and more expert in our fields, here's what happens. And this is very interesting. I'm sorry. I tried to move it, and that was probably a big mistake. As we get more and more expert in our fields, an interesting thing happens. We develop what researchers at Carnegie Mellon, Ken Kettinger and Michael Nathan, call the expert blind spot. And here's a good example of it. This was an experiment they did in which they took a high school algebra exam. And they asked high school teachers, middle school teachers, and elementary school teachers to rate how difficult this exam was. So they looked at the exam and tried to determine how difficult it would be for their students to take that exam. High school exam, remember? The worst were the high school teachers. The worst by far. Middle school teachers were a little better. Elementary school teachers were by far the best. They were closest to being the novices. So as we become imbued in the area in which we are experts, we lose touch with novice learners and the problems that they are having in learning. And finally, there is what I call the assessment blind spot. Higher education does virtually no scientific assessment on the effectiveness of any course, traditional or e-learning, as I'll talk about it in a minute, to determine whether it is really working, whether it's producing deep learning, by which I mean sustained learning, transferable learning, transferable from the classroom to the real world, and flexible knowledge. And what assessment is done is very seldom used to feed back into improving the class. Even as an individual faculty member, I can confess to you that I have very rarely, if ever, looked at the results of any assessments I did and gone back and said, okay, now how can I make the class better next time? There was always something more to move on to. So you don't get any kind of continuous improvement that we see throughout the commercial sector. I mean, you can find any diagram like this about continuous improvement of products. And what you're going to see in that diagram, this one happens to be from NASA, is measure the condition and compare it with some benchmark. And this isn't going to work if you don't measure whether what you're trying to do is being accomplished or not. Go back to the race car team. What do they do these days? They go out and buy a tremendous amount of electronics. And they instrument that car. They instrument the speedometer. They instrument the braking system, the wheels, the cooling system. And they put it in the car, and they get telemetry from the car to see what's working, what's not working, what combination do they need to change as the race is going and in the design of the car next time? Then there's the second problem we have, and it's connected with the first. Experts do not think or learn like most novice learners. The lecture model assumes that we do. That will be the problem in the room today. I bring to this a tremendous amount of work in this area. I have a certain set of mental models on how this all works, and I have in this room a diversity of mental models about teaching and learning that you bring to this. And we're sort of trying to find common ground. If I was talking with any one of you, Socrates talking with a student on the left, we would get to find common ground fairly easily because we would be dialoguing back and forth. We moved the Socratic model and we just sort of added a couple of students, and then we added a couple more students, and then we got to 800 students, and now we've gotten to distance education where we've got 8,000 students, right? And the Socratic model broke in there somewhere. Why? Because we don't have feedback loops, because we're not communicating to come to common ground. So here's the dilemma. Faculty cannot and should not be expected to play these three roles. And yet, all three of those roles are key to making higher education both more effective and more accessible. It is absolutely no good if we make higher education materials accessible on the web if they are not effective, if they do not support novice learners to learn. So just putting the material out there isn't enough. Now here comes the other half of the dilemma. But the economics of higher education suggest that it will be very hard to change the current model. It's cheaper to pay me as a professor to lecture to 800 students than it is to pay individual tutors to work with each of those 800 students. So we've got a problem. What are we going to do? Well, I always get to even worse, right? Even worse. As I mentioned before, we may be taking the wrong direction in the lecture class with distance education by increasing those numbers that we're lecturing at. So, can we fix this? In the words of our president-elect, yes we can. But it's going to take a team to do it. It's going to take that pit crew to do it. One of the most eloquent advocates of both the problem and the solution is himself a Nobel Prize winning Nobel laureate in physics named Carl Wyman, who teaches at the University of Colorado and the University of British Columbia. And he says roughly what I will be saying to you, have been saying to you. Research on how people learn, and he's focused on science learning. Research on how people learn science is now revealing how many teachers badly misinterpret what students are thinking and learning from traditional science classes and exams. However, research in cognitive science is also providing insights into how to